a little bit about how this all came about. I'm an agile engineering coach, and things that I care about in that role are feedback loops and team building and fun. And so we wanted to make build lights as part of what that all equates to in our world. And build lights are not anything new. Does anybody have any of any kind now? All right, so a couple people. Lots of options out there. There are some that I've seen people actually sell that you can buy. But we wanted to have it be a part of a team building exercise to figure out how to do it ourselves. And in that process, we bought a bulb and contacted the company to get a spec on how we might be able to communicate with it with our own code, and told them what we wanted to do. And they basically responded and said, that's a nice idea, but no. And they wouldn't tell us how to actually do it. So we said, challenge accepted, and set about to figure out how does the bulb actually work, how will we intercept the communication, and have our own code control the bulb to make these build lights. So that's what this whole process came from, was being told that we can't do something and then us wanting to figure it out. So what we're going to talk about here a little bit is just a little bit about Bluetooth Low Energy, how it works. I'm using TeamCity running in Docker container on my machine here. I have an Intel Edison to actually communicate with the bulb and have TeamCity talk to manage that communication. The Bluetooth bulb, and then we're going to do packet sniffing on that communication between the app that actually runs the bulb normally to reverse engineer how that communication works. We'll use Wireshark to inspect that protocol, and then we'll put it all together into our own package of code to be able to control it the way we want. I'll get to that. All right, so Bluetooth Low Energy. I'm sure everybody's familiar with it. Originally, it was actually called Bluetooth Smart, but BLE, Bluetooth Low Energy, is what we all call it now. And it uses this mechanism, one of them anyway, is generic attributes. You'll see it's generic attribute profiles, and they're basically key value pairs. So you have an address, a handle, and you give it a value, and that's how you actually have all the communication occur in this Bluetooth Low Energy, in this GATT profile mechanism. So TeamCity, I'm just running on my machine, like I said. Everybody's using something for continuous integration at this point, right? Anybody not? Okay. So I have it running in Docker on here, and then there are plugins that you can put into TeamCity, and I grabbed one that's called Webhooks, and it allows me to just have TeamCity do callbacks to any address with this particular structured payload, and that gives me what the status is of that build, whether it's passed, failed, or in progress. So that's what I'm pulling that in here. How many people are not using containers in any way? All right, so I would invest the time in learning about them soon if you haven't. This is kind of a really simple overview that I just grabbed from Docker on what they are. Does anybody not know what a container is? All right, so we can skip over this. All right, so I know this is hard to read on here, but basically this is that payload from the webhooks. And the main things that we care about in here are, I want to know the build result, which you see up here is failure in this sample here. And there's also a build status in here that says whether it's in progress right now or not. The state description, I think. Finished, running, or finished or started is what you get out of that. All right, so the Intel Edison. The Intel Edison is a really small form factor microcontroller that, well, actually, it's a full computer that Intel had out as their IoT, was one of the many IoT platforms that was put out. This is actually the Edison, just this chip here. The rest of this board is their Arduino Breakout board. And you can emulate an Arduino with the rest of this board, and you have all of the form factor headers on here to be able to use the shields on this as well. So it's a really nice chip in the IoT offering space, in my opinion. This is the specs on the Edison. Now, and then this is that Breakout board, like I said. You need something. That Edison is meant to actually be a production quality chip that you could use in whatever your real device is. So when you have just the Edison, you don't have anything that you can easily connect to it. There's actually a 70-pin header that you have to have. So I use the Arduino Breakout board. Now, I have some bad news about this, though. While I think this was a great platform, Intel has decided to abandon IoT devices. They've realized that it's too competitive of a market, and they don't really know how to operate in it, so they're getting out. However, good news is that the Raspberry Pi 3 has Wi-Fi and Bluetooth built in on it, so you should be able to use that and do the exact same thing, and you won't have to add any additional hardware, so that's good. You could not do the, I mean, could you? Yes, everything can be done. But the amount of work that you're going to have to go through is going to be quite extensive because an Arduino is just a microcontroller. And you need something to actually manage the Bluetooth stack and communicate. So the systems that are actually a full computing environment are going to be much simpler to deal with to set this up. So, all right. So the bulb that I'm using is a flux LED bulb. I don't know about how all of the Australian power stuff would work with this, so I don't know what to recommend in terms of, I mean, I assume a Hue or any other LED bulb should work, but this is what I got in the US and just bought it from BluetoothLightbulb.com. It was like 20 bucks for the bulb, and the app to control it is free, and they have an Android and iPhone app. And I'll run that in a minute to just kind of show you what it is. But in theory, this whole process should work with any bulb, any device. All right, so we're going to get into packet capturing on here. On Android devices, you can actually have it log all of the Bluetooth communication that it has between the phone and any device. And to do that, you go into the developer options and you turn on the Bluetooth HCI Snoop. And depending on the actual manufacturer of the device that you're using, that data is going to be logged to different locations. On the one that I have, it actually puts it on the SD card. But you'll just have to kind of research it and figure out for your particular vendor. And I think even now, certain versions of the OS put it in a different place too. So it's kind of a mess, but that's how you get this information easily. All right, anybody ever use Wireshark? Anybody not familiar with it at all? All right, so I think the best way to describe it is it's like Fiddler. Do you know what Fiddler is? All right, it's like that except deeper. Fiddler's just getting you application layer information, HTTP calls. Wireshark is all the way down the stack. I mean, you get down to your Ethernet frames that are actually going out on electrically. Like you can get the bits of what's really happening here for the whole Ethernet packet. And then it gives you a lot of tooling that's built into it to actually help you inspect that and decipher what those headers are and the addresses and everything else. So very, very powerful tool. And convenient for us, it also will work for Bluetooth. So we can actually get the Bluetooth stack has several layers to it. We just need the attribute profile layer out, and this can handle stripping that out of the whole packet for us and make it easier to get to. And then we're going to put this all together, and I have a node server that's going to be running on the Edison. And again, you should be able to run that on a Raspberry Pi 3. And then I'll have TeamCity running on my local machine that'll use the webhooks to make calls back to the Edison. And then there's a node package called Noble. It's Node Bluetooth Low Energy. And you can use that to easily do the communication for Bluetooth Low Energy. And then that will actually send the signals to the bulb to control it. So any questions about that? All right, and I'm running this all off of having the devices all communicate through my phone because conference Wi-Fi is never reliable enough for this. So hopefully this will all work well here. All right, well, let's do it. So first thing here is let me turn on my bulb and I'll run the app. All right, so this app, when it runs, it picks up whatever devices are out there, and it knows that it is a bulb that's compatible with this based on the identifiers on that broadcast address. So it's always going to be called LED blue dash and then a serial number that identifies like the version of the bulb. So it's picked that up, and I can connect to it. And then now I can simply just have it change the color of the bulb. You can do, they have these functions in here, so I could set it to do this red gradual change, and it just kind of pulses. And there are different colors you can pick for that. You can actually have it set to do to music. I mean, they have a lot of features in their app. We just kind of wanted to have, you know, a simple green for success, a red for failure, and then what we wanted was a pulsing blue for build is in progress. So that was what we set up. Now, to actually get data for what's this communication happening, how do we make this all work, it seemed logical to, I have the logging turned on. Well, I need to fill that log with repeating patterns so that I can easily find them and start to identify what is actually a signal that I'm intending to give the bulb versus all the other communication that might just be part of how the signal gets there and how the app talks to the bulb, right? So, hang on, it turned off on me. So to actually get that log data, you just want to turn it on and off a bunch of times. And maybe I'll rotate through the colors a bunch, and maybe I'll tap back and forth between a couple of colors so I want to get like a repeating pattern in the log, right? So that I can identify it when I see that, and that'll help me understand what might really be relevant here. So we filled up the log now. Now, I'm not actually going to move the log file from my phone because it's actually a huge pain to do. I already have brought one over here. So here is, oh, I guess I need to kill my presentation. All right, so here's Wireshark. So you take that log file, that Snoop log file directly off of your phone, and just tell Wireshark to load it. Just say open it, and it will handle everything. It'll recognize what it is. It's nice and easy. So this is the log file that I've pulled off of here. And I see all of this Bluetooth communication information in here. And I don't really know what any of this means. This is all basically nonsense to me at this point. So I just kind of continue to look through it, and I start to see this ATT thing, which I know is a way that generic attribute is often written when I'm reading things online. So I continue looking through this, and I see a bunch of these ATT statements in here. And I see this got these handles listed here. Let's kind of continue looking through here and see what we find, if anything meaningful stands out at us. So now I know from my original timestamps when I did this that it was further down in the log here when the time that actually happened. So I'm looking here and I see this write request stuff, and that seems like it's actually the device potentially telling the bulb to do something, right? So I see this handle of 0043, and it has this value. I don't know what these things mean at all, but I'm at least starting to get an idea of what might be useful to be looking for. So let's continue looking down. And here's another write request. Let's keep looking for some of those. All right, so here is where we'll start to see I was turning it on and off. And this looks like the same command being sent, but just toggling back and forth, right? So that might be useful for us to keep track of, that maybe this is how I turn it on and off. And as we continue to go down here further, we start to see some things that look like color values, maybe, that I'm on a wheel and I'm just making incremental changes, right? These addresses, this value here doesn't have a lot of changing to it. Let's keep going down further. And I started to discern the pattern here, right? That this is just a hex value of color in the middle of this packet. So that's also useful for us to keep track of. Now let's see how might we get the Edison to actually talk to the bulb directly and start playing around with it. So the IDE that they have for the Edison is the Intel XDK. And basically, it has an SSH terminal. It has a terminal that works over Bluetooth, but I'm just going to do the serial terminal here. And this is running Linux on here. Yocto Linux is what it's called. Linux has the Bluetooth stack. It's called BlueZ. And so you can go out and read about that and get an understanding of it. Well, there are a couple of tools that come in that stack. And one of those is called GATT tool, G-A-T-T tool. And that's what we're going to use to actually try to connect to the bulb and send these packets and see what happens. One of the first things we need to do, though, before we can do that, is figure out what's the actual address for this bulb. Because when we want to use GATT tool, it's expecting us to give it an address to actually connect to. So we have to find that. So to get that address, let me disconnect the phone. So one of the things that you'll learn about the Bluetooth devices is, these BLE devices, is when they first power on, they just start broadcasting that they're available to connect to. And then as soon as something connects to it, it stops that broadcast. And it won't listen for another connect request. So I have to actually tell it to disconnect. I have to have the phone disconnect from the bulb so that the bulb will listen again. All right. So I'm going to power cycle the bulb here. And then there's another tool called Bluetooth CTL. And this is now just talking to the Bluetooth controller on the Edison. And I can issue certain commands to it. So I'm going to tell it to do a scan. Now, whenever I do this at a conference venue, I've already actually recorded the address of this because at a conference venue, there's so much Bluetooth traffic that it's impossible to sort through it and find it. And sometimes this actually makes the Edison crash and I have to restart it, but it's still kind of fun to see. So I'm going to turn this on and then try to turn it off real fast. Those are all of the Bluetooth devices out there right now that are broadcasting their address. And if you allow it to run longer, some of them, oh, hey, look, there's the bulb, actually. We were able to find it. Here's some camera in the mix there, a tile, Alta. So you start to see what some of the things are. And you can also, I've seen people use this to be able to actually track the Bluetooth devices where they are located because you get your signal strength on some of these as well. So anyway, that itself is just like a fun thing to play with in large places and see what all's out there among the crowd that you're in. So we have the address now there, though. And as I said, I already grabbed it earlier. So now we can use this GATT tool and give it that address. And I'm going to go into interactive mode. So you can actually have just single statements that you pass through GATT tool and single command line executions. But I'm going to go in interactive mode. So the first thing we need to do is connect to the bulb. All right, so now we're connected. And let's see what we can do here. If we take one of these, and we want to do, as you see here, this is this write command. If you go read the spec, that ties to this char write request. So I'm going to send it a write request to that handle of 00, actually I do need to say that, 0043, and we'll give it this value. I don't know, did it actually change? Let's go back to the power on and off. That might be easier to play with first. All right, so let's take that one. Oh, it didn't even copy my value the right way. Okay, CC 2433. All right, bulb turned off. And if we look through here at these other packets, so the difference on this one was 2333. So let's change that. And the bulb's back on. That is so much fun. Every time I do that, like, just being able to press keys and make the bulb turn on and off, I love it. All right, so now we know how to turn the bulb on and off. Let's go back to where the colors show up. All right, so actually I'm going to just copy this out of the code because it isn't copying it properly from Wireshark. So, all right, so let's throw this value in here. So I've set this to be just green. So let's see if this works. It did not. I got disconnected. All right, I reconnected to it. Let's see what happens. There we go. It's green. So that must mean then that that should be red. And so it actually, I mean, that is what it is, but it doesn't actually respond to that. Or black. And we want 1, 2, 3. There we go. So there's blue. All right. So I don't actually have it in this packet log for the pulsing color, but that is one of the things that I already have in my code here. So I'll just grab it and we can test that. Oh, one of the things too here, so you'll see in this write method, we'll come back through more of this, but I'm not always writing to this handle. I'm sometimes writing to 2E. And what I found was once I added more bulbs, the address, remember when I first brought up the on the phone and it's LED blue dash and then an identifier? Well, I've discovered 2 versions at least of the bulb. And if it starts with a 7 in that identifier, then the handle is 43. If it starts with an 8, then the handle is 2E. So you may have those kind of difficulties if you try to do this and have different versions of the bulbs that you're interacting with. Okay, let me find this real quick here. So here we go. All right, build finished, build started. So this is the value for build started, and this should be the pulsing blue. Yeah. So what I found with this is on that app, you can actually change the speed of the pulsing on the bulb, and that speed is controlled by, I think, this 3-4 here. I don't remember what it is, but everything about it, everything you saw the app doing, can all be toggled as part of the values that you're sending, and usually they're paired together in some way. So that speed of the change is actually embedded in this. I just don't remember what it is. I just chose this speed and it was fine. So any questions about that so far?
So to sum up, the technologies you're using is Wireshark, Edison, and what else?
I mean, across all of it, I'm about to bring in TeamCity. So I have TeamCity running my builds. It then uses a plugin called webhooks to make callbacks to the Edison, which will have a node server running on there listening for those. And then it uses an NPM package called Noble to actually send the packets off to the bulb. Yeah, I guess that's it. And then the bulb. Yeah, the bulb is connected via Bluetooth. Yes. Yep. All right. So now let's take a look over at TeamCity here. So as I said, I have this running in a Docker container. And I've got both the server and the agent running on my machine here. And what I have set up in TeamCity is just a dumb build that reports failure or success based on it's just a command line statement that is built or running, and I just have it echo fail or not. And then the failure condition is looking to see, is that text in the output? And if it is, that's how TeamCity is registering this as a failure. Obviously, this isn't how you would really set this up, right? But just for demo purposes. So then there is this plugin, webhooks, that you just download. There's a link on TeamCity's website in their plugin list for this webhooks plugin. And you just upload the plugin zip, and it will install it. And then on every level, so you can do it at like a whole project level, or you can do it at a specific configuration level. I think you can actually do them at a server level even too. You can then set up these webhooks. So, and I'm actually going to change that address. So that's where it's getting tied in to make those callbacks to the Edison when the build process is running. Any questions about that part? All right. So now let's go back over to the Edison, and let's take a look at some more of this code that I have in here. So, and a disclaimer, this is not how I write production code. This is just us hacking around and having fun, and so we just, it's sloppy. All right, so there are a couple of things that we needed. We needed a place to be able to have the Edison actually listen for that callback data, but then we also needed to give it some configuration information because we had multiple bulbs that we were bringing into the mix as well. And there's actually no identifier on the bulb itself to tell you which bulb is which. Hang on one second here. Let me run this. Actually, it should be okay. So there's no identifier on the bulb itself that tells you what its address is. So you just kind of have to play with it and figure it out. So we all right, so now I have, this is our code that we wrote to do all this. And I'll need to, I think I have to power cycle this again because this app is now running and needs to pick it up itself. All right, hang on. Let me restart this. I had that GAT tool still open while I started the actual app, and they conflicted with each other. Okay, so it was listening. The bulb was broadcasting. It saw the discovery for that LED blue, and then it immediately grabbed a hold of it and connected. So the app that's running on the Edison is now talking to the bulb. And as you saw, it just set it to green. That's our sort of default state. So in the web app here, we just get that the IDs of what all the bulbs are. And then we added an identify feature here and just have it cycle through the colors. So we could actually identify visually which bulb was associated with that identifier. And then when this launches up, it actually uses the TeamCity APIs and gets the list of all the build configurations that are out there. And we just have the one. So you can then assign those two together. So now this bulb would be linked to this actual project here. So let's look through the code just a little more. So this is coming in, and when we have a build started for that notify type in that webhook package, we just send it that this is the signal for that pulsing blue that we did earlier. And then when a build finished and is success, we give it green. And when a build finished and result is failure, we give it red. And then we do have some occasions where you might have a build interrupted for a variety of reasons. And we had it go, what is that? I guess purple? No. What is red and green? I don't know. Is it brown? Okay. Yeah, I guess that makes sense. So so we get a brown color. Yeah.
Additive is yellow, isn't it? Additive, subtractive is
That's what I was trying to figure out. Is it?
yellow.
Okay. Yes, that makes sense. Yeah. So yes, yellow is the we don't know what's really going on. It was interrupted. So that's really all that's happening in here. And we have this send command that is, which is what we looked at earlier here. So actually, the first thing it does, we found that Bluetooth Low Energy is a little finicky. And so you might be connected, and for no obvious reason, you just get disconnected, which actually you saw happen when I was using the GAT tool earlier. I sent the write request, and it was just disconnected for no good reason. So I basically just have a if not connected, connect in every time we send a command to keep it working. And then depending on the version of the bulb, if its peripheral name starts with an 8, we use 2E. Otherwise, we use 4.3 right now. So I have no idea how long this list could grow. And again, the company has not told me anything when I've asked them for follow-up on any help at all. So, and the rest of this is pretty straightforward. We're listening to, when it boots up, this is the setup for being able to actually talk to TeamCity and get the list of build configs that are out there. And yeah, I think that's pretty much. I mean, I don't think we need to go through all the details of the code. Like you can write the code. Just that's the general gist of it. All right, so now let's actually fire off on TeamCity and put it all together here and watch it happen. So this should be a fail condition. Oh, I said I needed to change that IP address, didn't I? I did not change that yet. Yeah, but we just won't have anything happen on the bulb. OK, so I need to get the address from the Edison. IF. All right, and then I need to change the webhook. All right, and unfortunately, I may have to restart TeamCity because this is one of the problems with the webhooks. If the webhook fires and attempts to actually talk to something and can't, it does not fail gracefully. It actually just blows up under the hood. So yeah, I didn't write that code. So let me restart that real fast.
So how did you make your selection of all these tools? Did you just have intimate knowledge of all these applications
I mean, so we were using TeamCity, so that choice was already made. Yeah. The Edison I had already for, like I have a variety of IoT devices, just playing with them. And at the time, it was the only one that had Wi-Fi and Bluetooth built in. So that was easy, just sort of, OK, well, let me see if I can make it work with this. The bulb was just sort of randomly chosen. I mean, I guess that's all of it, right? Yeah. The rest just kind of fills in the gaps.
And then the software side, you just base on your hardware choices, right?
Yeah. Yeah. I mean, it could have been written in anything, right? Like, it didn't have to be a node that's the server running on here. It didn't have to be Express that's the server. You just pick whatever you want. Like, you could have done it in Python just as well. Python has a lot of BLE libraries for it as well. So, and the same idea should work across with whatever language and structure, right? Like the real interesting part here was the reverse engineering the protocol for the bulb. That was the part that we didn't know how to do. All the rest of it was just writing code. We know how to do that. We know how to have TeamCity work. We know how to do those bits. It was really the figuring out, can we actually figure out how this bulb is working and then have our own code control it?
So you monitored the packets with Wireshark and then basically just
Reconstruct them with our own code.
yeah.
Yeah. Yep, exactly. All right, so this is restarted. The agent reconnected. Let me make sure, save my webhook setting change. OK, so now we should be good. It is, yes. Yeah. So the agent, all right, so it worked. So the agent seems to be, there's like a decent lag between the agent and the server. And the webhook fires when the agent fires. And then the server gets updated after the fact. So that seems to be what's happening. All right, now we don't want to see red. That's not satisfying. We want to see green. So let's go in here and exactly, yeah. All right, so let's run this again.
It's more responsive than the page.
Well, that's what I was saying, is the agent seems to trigger the webhook call immediately and then updates the server afterward. So, all right, there we go. We're green. So isn't that exciting? Like, it's fun. All right, so the last little bit here, I'm not going to get into super deep with it, but let's say you had devices that you don't have an app for, that you have Bluetooth low energy devices that talk to each other, and you want to be able to get into that, and you can't capture the packets from an app on a phone to do it. Well, that's where the Ubertooth comes in. So Ubertooth is not technically Bluetooth on purpose, and for one reason. The real Bluetooth spec requires, and if you're going to put the label on there, you have to adhere to it, requires that a Bluetooth device only accept and pass on packets that are addressed to it, or broadcast packets, which are addressed to everything. The Ubertooth says, I'm just going to take everything I see. So you can have an Ubertooth, and as long as the communication is not encrypted, which BLE isn't, you can intercept all the BLE packets and actually record them off. Now, you can have encryption within the communication itself, just to be clear. Like, the data, though, itself is just still standard BLE packets. However, if you happen to capture the communication when the pairing occurs, you can man in the middle, basically, and get the pairing key, which is what controls the whole encryption that would take place afterward. So you can still get all the data. So Bluetooth Low Energy is really bad for medical devices. I don't know why people are thinking about like using it and talking about it like it's so simple, we should just do that. That's a terrible idea. All that data is going to be easy to sniff and grab out of the air. So, but yeah, Ubertooth is terrifying. And the one thing that you'll have to, if you do decide to go this way, and this is hard mode. Like, this was easy. This is way harder. If you decide to use something like an Ubertooth to try to intercept packets of communication, there are multiple channels that Bluetooth can communicate on. And your cellular device is actually going to switch among those channels when it's listening for broadcasts. The Ubertooth only has one radio in it. And it's a really dumb device. And you have to tell it what channel to be on. And if you don't tell it, it's just going to default to one of them. So just sort of a pro tip, if you do try to use it and you are finding that you're not getting data for some reason, it's probably because the device is broadcasting on a different channel. And you'll have to go in and change that. And this also works through Wireshark. You're going to set up a first in, first out buffer on your machine. All that data will just come straight into Wireshark, and Wireshark can pull all of that off. But like at the command line setup is when you're going to have to change the channel potentially in terms of what you're looking at. So there's that if you don't have an app and you want to know how to do this. Same exact process, just you need to get an Ubertooth to be able to grab the communication instead of logging it off on a mobile device. So any questions about any of this? Anything that you want me to go over again? Any ideas or questions that you might have for particular scenarios you're looking at?
What are the other IoT devices?
What's the question?
What are the other devices, IoT devices?
I mean, so like I think Fitbit has an API, so I don't think you would have to really have an issue. You know, like they're not going to tell you no, you can't get the data because they're all about the data, right? But that's a thing that you could do as well. And I used the Ubertooth and sniffed the communication off of Fitbit just to see, you know, how would that work? And same thing, you can get all that data. I mean, lights have easy applications because of being able to control them and have visual feedback for things. But any Bluetooth low energy device you could do this with. I mean, I don't, whatever, right? Like a lot of the wearable devices are all BLE, so you can get the data off of those or your neighbors.
You used an Arduino to do the comms of Bluetooth, but presumably you could just do that straight through your laptop.
Yes, that is true as well. Yeah, you could. So I actually didn't use an Arduino. I used an Intel Edison to do that. So yeah, you could do it straight through your laptop. We, at the company that I was at, all of our CI was done in the cloud. And so our TeamCity server wasn't on-prem anywhere. And we needed something on-prem that could do this and actually talk to the bulbs in our office. And we didn't want to have a computer that was dedicated to it because all of us just had our individual laptops and that was it. We had nothing else in the office for that. So getting a microcontroller to do this was much easier and a lot cheaper and cooler. That's right. Yeah. Yeah. Our clients, when they would come in and they would see the bulbs and they would see and we didn't use the large form factor. There's another breakout board you can get that's just slightly bigger than the chip itself. And when our clients would come in, it was a good talking piece, you know, a showpiece kind of thing to have them see it, and they got all excited about it. And seeing the bulbs go off while they were in the office was always fun.
So you could also, instead of using Raspberry Pi 3, the Raspberry Pi Zero now has a Wi-Fi version, Raspberry Pi Zero-W.
Does it have Bluetooth on it as well?
Oh, my apologies.
I don't know if it does.
That I'm not sure.
Okay, I know the 3 has both. So, but I mean, you can get separate Bluetooth, you know, separate BLE device chips that you can just put on whatever you already have. It's just easier if you don't have to deal with all that.
So you were saying, though, that if WebHawks wants to communicate to an address and it's not there, it effectively crashes?
It seems to, yes.
So does that mean then in a commercial environment, your teammates might look badly upon you if you crash TeamCity?
Yes. So don't do that. I mean, it wasn't a big deal for us, again, because our stuff all lived in the cloud. Like, we had TeamCity crash on us like 3 or 4 times when we were first getting this set up, and it was not a big deal for us to just go out and restart it. And you know, but once we knew that was the issue, then we just made sure we didn't do that anymore, and it wasn't ever a problem again.
You didn't have another light that flashed red when someone else crashed TeamCity?
No, we don't have that one. Yeah. The other thing about the Edison is it's powerful enough to be able to run a VPN on it. And so that was how we got it tied into our CI environment, was we had OpenVPN client on the Edison, so it could just connect in. And then we had our DHCP give it a specific address every time, and that was how TeamCity then could talk back to it. Oh, okay, perfect, yeah. Yeah, the Edison is pretty powerful, and I mean, and it was the most powerful at the time. I assume the Raspberry Pi 3 is powerful enough to run a VPN on at this point, but running a VPN is pretty computationally intense, and a lot of IoT devices choke if you try to do it. But I think that they're getting to the point now where they're powerful enough they can handle it, or at least close enough.
That then might rule out the Pi Zero.
Oh, yeah, that might, yeah. Yep. Any other questions about this? Anybody want to see it again?
Sure. Do you see the irony that you used Edison to turn on a light bulb?
I know. Yes. A Tesla would have been right out. All right, well, that's it. Thank you very much.